And welcome, everybody. Thanks for tuning in to the Daily Space Weather. A lot of interesting stuff happening with the sun and other stuff. We'll be talking brown dwarfs. We'll be talking about the new beta-class sunspot that's just risen, Sunspot 2795. We're currently in a state of geomagnetic unrest, and geomagnetic storm is forecasted. Also a solar flare watch, according to me. First thing we're looking at is a colorized magnetogram here, and you can see this beta-class sunspot having just risen, Sunspot 2795, and we can see multiple umbrae there, and they are most assuredly of opposite polarity, and that's the increase in the solar flare potential. Beta-class sunspots having two opposite polarities more likely to cause solar flares, and a slight increase in the likelihood of coronal mass ejections. Also, now we're looking at Comet Erasmus, and we've brought about 3 days of data there from the LASCO C3. You can also see Mercury sneaking in behind the aperture arm on the LASCO C3. Great view of those scenarios. And the 10.7 centimeter radial flux has jumped up to 86. No surprise there, as we've got two sunspot groups. There's the 1 year chart of the radial flux. And again, geomagnetic storms have been forecasted for late in the day at 2100 hours today on December 23rd. Also early in the day tomorrow on Christmas Eve. And for you new viewers, thanks for tuning in, by the way. Thanks to our new YouTube subscribers, etc. The radial flux, a measurement of the outer coronal radio output, is directly proportional to sunspot number. So there's the last solar cycle and the beginning of this cycle 25 progression in sunspot number, and there it is in radial flux. Next, we're looking at the intensity gram here to show you that rising set of sunspots. And again, multiple umbrae there. You can see two different sets of umbrae, opposite polarities, making it a beta-class sunspot. Next, we'll take a quick look at the fields and then move on to a couple helioviewer movies. There's the most current image of the fields, and here's the fade to 171 and 94 angstroms. 304 angstroms. Yes, yes. Next, we'll look at Lagrange point 5 before we show you a couple helioviewer movies and then move into more data. Lagrange point 5, that's where that's located there. A few months behind the Earth, orbitally speaking. And here's the view from stereo A, and we can see some plasma now out in the coronal region. You can also see Venus behind the coronagraph out there at stereo A at Lagrange point 5. And let me just check the life of the stream here before I show you a couple helioviewer movies. And we are good. Thanks for tuning in, Life Force Rejuvenation. What? How are things, Mr. Katowski? So here's a mostly full disk view in 304 angstroms. And since for some reason I cut off the North Pole today, I don't know why. It was some kind of a senior moment, I guess. We'll show you a zoom in of the North solar polar region here in this same wavelength, 304 angstroms. The UV emission spectra of very, very hot helium, which is missing an electron. So here's that top view. Allow me to vanish. And thanks for leaving comments, John, on Twitch. And you can see some filamentary activity there in the northwest. Also, I would note some minor crown prominences happening up here, an indication of higher levels of solar activity. We only see crown prominences, especially large ones, around solar maximum. And we don't always get to see that. Today we do. And next, I'd like to thank our patrons, the true source of funding for the content. People like Life Force Rejuvenation here. Thanks, patrons. Please consider becoming a patron, increasing the probability that these videos will continue to exist and remain free and publicly visible. Patreon.com/smAshoMash. You get all kinds of updates and free stuff nobody else gets. Next, looking at the Southern Hemisphere here in 304 angstroms. And we're going to hold off on the rest of our Helio Viewer movies until the end of the video. Great view of that active region, and it's quite a large active region there associated with Sunspot 2794 and the new Sunspot 2795. And thanks for leaving a comment also, JapDX. Yes, your first time on Twitch. Yes, thanks for tuning in, Twitch viewers. Cheers. And thanks to our new followers over there as well. Next, I would direct all of our viewers to check out smAshoMash.com. There are all kinds of links for you there on that site. You can also get redirected there at smAshoMash.org. You'll find our social media there on the right, behind that little arrow. Also links to the forum and the stores. And for instance, if you pick up anything at the store, make sure you enter the promo code smAsho to save 10% on all orders at checkout through Christmas. So thanks to the Smash team, everybody who's ordered merch, etc. Again, enter the promo code smAsho to save 10% on all orders through Christmas. And again, you can find all the links to that stuff, including the forum as well. And there are cosmology, earth and geophysics, heliophysics, free-for-all forum stuff. It's all free at smAshoMash.com/forum. You can also read about our mission at smAshoMash.com/forum/mission. Don't forget to follow us on Twitter, and there are links to the Teespring stores there as well. Twitter.com, everything at smAshoMash. Thanks to our new subscribers over on YouTube. Cheers. And I'll take a moment to allow you to press like and subscribe. Don't worry, we'll be here when you come back. Maybe press that share button and share on your social media, especially if you've got thousands of friends in places like, I don't know, Facebook. Also, check out our playlists, youtube.com/smAshoMash/playlists. You may see things like smAshoMash.org presents The Sun, Part 9, all kinds of close-up images, some with music, some in sheer silence. Because in space, no one can hear you scream. And I'm back to show you a diagram of the solar system. And if you got images of the great conjunction between Jupiter and Saturn, hit us up, drop us an email, hit us up on social media. Perhaps we'll feature your content on the Daily Space Weather. Here's where stuff is in the solar system now. There's where it'll be tomorrow on Christmas Eve. And there's where things will be on the second last day of the year, December 30th. And it looks like a full moon. Indeed, that is the full moon day, December 30th. I like to use in-the-sky.org for my star charts. And please leave us a comment if you're very scared and spooked that Uranus has moved into Taurus and now Moloch is coming to eat your babies. A dingo didn't eat your babies. Moloch came to eat your babies. Again, thanks for viewing on Twitch. We don't always stream live to Twitch, but it is such a good platform that, we like to regularly use it here at the Smash News Network. Again, they've got a great mobile app as well. You can download that for free. You'll get notifications when we go live. We also do stream live to YouTube. Again, it's youtube.com/smAshoMash. And we're all over all of the social medias. We may do a Smashlight segment later today, not exactly sure on that, but we're definitely going to do a cosmology segment as we've got an interesting story about brown dwarfs. First, we're going to pick a random number between 1 and 1031. Using our quantum number generator, today's random number is 743. Why? Because that's an entry in the Neil Gorell Swift-Bat X-ray Observatory. 743 is today's randomly quantum selected object, which is GX 5-1 a low-mass X-ray binary/neutron star, otherwise known as the catchy name 4U1758-25, GX5-1, and check out the X-ray emissions on that. It's got quite a normal range here. There's the historic graph over the past 14 years of its X-ray output, and it looks quite variable. An interesting object there. GX5.1, low-mass X-ray binary/neutron star. So here's a visualization of it. That's SIMBAD. You can click directly on that from the transients page at the Neil Gorell Swift BAT X-ray Observatory. And BAT stands for Burst Alert Telescope. There are telescopes all around the world monitoring these objects. Let's look at it in a couple more wavelengths. So this one here is optical. Let's take a look at it in X-ray, as it should show up on the Chandra. And maybe not. Some object next to it, though. Sup with that. And let's look at it on the 2-mass, which is the infrared band. And there is 4U1758-25 in infrared. We'll zoom out here to show you where it's located in terms of the galactic plane. Looks like it's on the galactic plane. And there's the zoom out to the Milky Way galaxy. Today's featured cosmology object, 4U1758-25, presented randomly on the Daily Space Weather. Let's talk brown dwarfs. Here's 2 brown dwarfs. These are like 17 times and 8 times the mass of Jupiter. That's not a real image. That is just an artist's rendition. Why? Because brown dwarfs are only visible in infrared spectrum. So there's an article about this one. And these are located about 450 light years away. Pretty great that they were able to be spotted. It's Ophiuchus 98A and B. So you can find a link to that at scitechdaily.com. It's scitechdaily.com. Again, Ophiuchus 98A and B. And these orbit each other at a very great distance, about 200 times the distance between the Earth and Sun, or 5 times the distance between the Sun and Pluto. And the brown dwarfs are almost like a little star or a big Jupiter. It's not Nibiru. Again, they're 450 light years away, and I'm going to vanish like people's fears of Nibiru. Perhaps have a read about that. And that's today's cosmology segment. Let's get back to data. As we've seen a geomagnetic state of unrest kick off as a result of incoming solar protons, high-speed ones, in that the current solar wind speed is well over 600 kilometers a second, at about 628 kilometers a second. So we see a low density but a high speed, enough to create a state of geomagnetic unrest. Unrest. Solar wind density only 2.06 protons per cubic centimeter. So a low density and a high speed is enough to create that, a KP of 4. And the KP index, for you new viewers, is a measurement of global geomagnetism. Anyway, there's a 3-day chart of that. And let's take a look at some visualizations here. You're going to see the density drop off. And there's the density dropping off. Low density here shown in white, high density shown in dark blue. And before we show you the pressure, let me just check the life of the stream once again. Again, thanks everybody for leaving comments on Twitch. And here's the pressure. And you're going to see the pressure kick up here at the same time as the density drops down. Actually, you're going to see the pressure kick down. There's the high pressure mode. And this is a measurement in nanopascals. It is a model. It's 4 hours of data. Wow. Did we have missing data there? Nope, just a major drop-off in the density, causing a major drop-off in the pressure. There you can see that. And that visualization is based on the space weather modeling framework. You can read all about this. For example, on the Space Weather Enthusiast dashboard, if you scroll down to the bottom, you'll see all these links. This is the Geospace Magnetosphere movie right there. And if you want to read about the Space Weather Modeling Framework, just click on Details, and that's the link to the Space Weather Modeling Framework. It'll tell you all about how the data is derived. It's from a lot of different data points, everything from the electron flux to all kinds of magnetometers, both in space and on Earth. So there's a great view of that pressure drop-off as a result of the density drop-off. There are also issues with the current sheet, not the galactic current sheet. That's ridiculous. First, before we talk about that, we're going to talk about ground magnetic perturbations, and we see serious ones here. Some more serious auroras will have been kicked off as well. We're not going to cover it today. You can link to all of that stuff from the Space Weather Enthusiast dashboard and from all kinds of other different sites. Look up the auroral 30-minute forecast. Anyway, there's 4 hours of data of what's going on at the poles in terms of changes in the Earth's B field. And here is the global view. And we see some significant magnetic pulsations happening here. Keep in mind the South Pole has left the Antarctic continent entirely. We've got 2 North Poles, one over northern Canada and one over Siberia, making the net pole someplace in between Svalbard and Greenland. And you may see some auroras a little farther south. Actually, let's bring up just the auroral image here real quick. And just give me one moment. Again, we are streaming live. All right. So there's the current auroral image. That one from 9:41 Universal Time. Some likelihood of auroras visible even in southern Alaska there, it looks like. Nothing visible yet, according to this forecast for Australia. Next, looking at the proton flux, we don't see any major proton events happening, as we haven't seen any coronal mass ejections. So there's a 3-day chart of that. And we see a little uptick in the X-ray flux here. Again, the likelihood of solar flares has gone up with the appearance of that beta-class sunspot group, 2795. And here's the GOES magnetometer, and we're seeing very spiky readings here over the past 3 days, and it all has to do with the polarity of the current sheet. We'll show you in the next slide. Again, that's 3 days of data. And we'll see this smooth out here once the coronal hole wind stream ends. And here's what we're talking about with the current sheet polarity. So if I bring up the last image, you can see the Earth is currently in the South Pole current sheet, shown here in red. And we're about to be back in the North Pole current sheet, so expect to see continued spikiness throughout the duration of the geomagnetic storm forecasts. Expect us to be back into the green portion, the North Pole oriented current sheet, I would say by tomorrow when we do the daily space weather. Next, looking at the coronal hole field plot, which also shows you the line of sight view here. You can see the solar B field shown in blue. The B field is the one that goes through a magnet, and we were just looking at ground magnetic perturbations. Those are changes in the Earth's B field. This is the sun's B field. And we see a significant coronal hole there, South Pole oriented, just in front of Sunspot 2794, which is where that South Pole polarity came from. And here's a different view of the same data. Essentially, this also shows you the magnetogram, as well as the solar poloidal fields. The solar polar fields shown there in green and red. Last but not least, we'll show you the magnetic field plot of the sun's atmosphere, known as the corona. Let me blow that up. There we go. And a chaotic environment the sun's atmosphere indeed is. Next, we'll look at the Earth's atmosphere in terms of what's going on with the electrons. And we see some charging hazards here, but they have actually simmered down since I did show prep. A little bit of charging hazards there over northern South America, Central America, and Mexico. Here's the 1-year graph of the relativistic electron flux, and we're talking about the electrons in the Van Allen belts. That's courtesy Solon.info. And we see a bit of an odd forecast here once again. NOAA is jumping the gun with this electron forecast. That's going to stay level until the geomagnetic storm ends. Then it's going to spike up. So I would agree with this, just not with this. It's going to look more like this. We're going to see flat and then a precipitous increase, but not until the coronal hole wind stream ends. So here's a 3-day chart, and that's measured by the GOES-16, which measures the electron flux at the F layer of the ionosphere. Here's a visualization of the whole air column. And everything's looking pretty normal there. For you new viewers, we see the highest levels of electron flux and indeed GPS errors around the equator at noontime. So here's just a diagram of where the Van Allen belts are, altitudes of GPS satellites, spacecraft like the International Space Station in miles. Here's a different view of the atmosphere, showing you the penetration of electromagnetic radiation from the sun, from X-rays down to visible light and IR. And if you see that red F on the right side, that's the F layer of the ionosphere. That's where the GOES-16 attempts to make its measurements. Keep in mind, these altitudes change during times of geomagnetic storm as we're currently experiencing. So next we'll look at a visualization of the whole ionosphere. And we see sudden charge ups and charge downs there. You see very low levels of charge there. Over Africa. And this is just one slice of the atmosphere, folks. This is just around the F portion of the ionosphere. That's 24 hours of data based on Australian Government Bureau of Meteorology. Here's the latest image, that one coming in at 9 o'clock Universal Time. Not particularly anomalous there, but again, some sudden charge ups and charge downs. Next, we're going to look at volcanoes, as we're interested in what's erupting. Is there some kind of physics relationship between solar activity and volcanoes? Perhaps. Sakurajima is erupting. It's producing a 6,000-foot ash plume. Suwanosejima, similar ash plume there. Popocatépetl down in Mexico is exploding, producing a 19,000-foot ash plume. Revenador also exploding, 15,000-foot ash plume there. And while we're unable to detect whether or not Sabancaya down in Peru is erupting, please do not attempt a tightrope walk over the caldera. It could be unhealthful and logistically taxing. Next, looking at the GFS forecast for pressure. Here's what's going on in the current pressure situation. We're right about there. And we'll just advance this into tomorrow as a low pressure area goes from the Great Lakes region of the U.S. into Canada. There's where the GFS forecast predicts things to be at 12 noon tomorrow. A double high pressure system over the North Atlantic, as well as over the North Central Rockies, and a series of low pressure systems there over the North Pacific. We continue to see an earthquake drought, and here's the USGS map of earthquakes over the past 24 hours. We don't see any major earthquakes. In fact, we see a drought of 6, 7, 8, and 9 magnitude quakes. Small deep quake over under Chile, nearly at 100 kilometers depth. It's a 4.5 magnitude. And let me just check the life of the stream before I move on here. And again, deal with your comments. Again, thanks everybody for leaving comments there. Life Force Rejuvenation and AJAPDX. Here at the Smash News Network, we greatly appreciate your comments, whether you view the YouTube live premiere event or you view in syndication. Tell your friends, your foes, your science noobs and science pros to leave us a nice comment or even a mean comment. You will not offend me, I promise. But don't make a fool of yourself in the comment section. we may berate you. Here's a 4.5 deep quake under Japan. It's at 120 kilometers. As the earthquake drought continues, largest of the past 24 was a 5.8 right there, southwest of Mexico. A couple small deep quakes there. Couple small deep quakes associated with Alaska, in the Aleutians and southern Alaska. And some quakes striking Hawaii also. Were you aware that Kilauea has started erupting again? There's a quake under Hawaii. And let's go back to windy.com real quick. I want to check the sulfur dioxide content. Windy.com, who has a great mobile app, by the way. You can download that for free if you like. And let's check the sulfur dioxide content of the Pacific Ocean. By the way, that's Popocatépetl down in Mexico. And let's move out into the Pacific Ocean here and check it out. Kilauea looks like it's certainly still erupting, producing a very dense area of sulfur dioxide. And let's move on to more stuff, more meteorological data. We'll take a look at the jet streams. A great snapshot for worldwide weather forecasting. So there are the jet streams of the eastern world. Significant low pressure system rotating clockwise here, northeast of Australia. Here are the jet Here are the jet streams of the western world. They are all over the place. We've got a doubled up jet stream there over the eastern U.S., as well as extreme cold air being funneled into the northern Rockies from Canada, and warm air striking the southern tip of Greenland, causing people to say, oh noes, Greenland is melting. And speaking of Greenland melting, let's go back to windy.com again and show you how melty Greenland is, since it's so hot up there. It's so hot in Greenland that it's totally melted, pardon my sarcasm. It's got 5 meters of snow from coast to coast all summer. There you go. There's how melted Greenland is. Oh noes, this area only has a foot of snow. This area has more than 5 meters of snow. And if you look more closely, there are 5 meters of snow on top of sea ice right there. That's the Atlantic Ocean, folks. Oh my God, Greenland is melting. Stop the presses. Next, looking at lightningmaps.org, it's where I go when I hear thunder. It'll even allow you to forecast thunder. And we see significant lightning there over the Atlantic. Here's a visualization on the GOES 16 lightning mapper. Here's a U.S. Doppler radar map as we show you value-added services. Heavy snow over the Dakotas and Nebraska. Here's a snow forecast on Tropical Tidbits. And if you're wondering where this comes from, just click on Forecast Models from tropicaltidbits.com. Head down here, click Precip Moisture. This is the total snowfall, 10-to-1 snow-liquid ratio. And that is the forecast through New Year. Now that's a bit of a long forecast there, as that's over a week out. And we're expecting some heavy rains here in eastern Pennsylvania, which will make it probably not a white Christmas. Significant snow there forecasted for West Virginia, western Pennsylvania. as well as the north central portion of the country there. Again, if you're getting more than about 4 days out in a snow forecast, folks, take it with a grain of salt and perhaps with a truckload. And next we're looking at the NASA GOES shortwave radiation map to see what's going on in the cloud layer. Massive portion of low clouds here over the northern Atlantic once again, as well as some interesting low cloud formations over the Gulf of Mexico. And here's what's going on in the water vapor layer. Again, there's the clouds, and there's the water vapor. Yes, I know, they look vastly different, don't they? It's because the water vapor satellite can see water vapor not yet condensed onto clouds. And this will give you great insight into what's going on the Doppler radar. If you're confused by the Doppler radar, we're going to show you a water vapor map for the Great Lakes region, as there's some significant snow falling in that area. It's another one of our value-added services. Actually, let's move that a little bit to the west. We'll center that over Iowa. There we go. And that should give you some insight that may be lacking on the Doppler radar. And we've got bonus features here. We're going to show you close-up images of the sun, the most current colorized magnetogram, as well as the intensitygram of Sunspot 2794 and 95. So here's the colorized magnetogram. That's Sunspot 2794, and there's 2795. And you can see certainly two different polarity umbrae there, making it a beta class sunspot. And there's the intensitygram. And that is a significant sunspot there, 2795. Again, that is increasing the likelihood of solar flares and indeed coronal mass ejections, as we do see some filamentary plasma in that area once again. And let's get to our final HelioViewer movies here. Here is an animation of the magnetism. And not sure, it looks like the leading umbra of Sunspot 2795 is actually shrinking, if I had to guess, which I don't. Anyway, there's the magnetogram in full animated glory. Here's the same view in 171 angstroms. My favorite wavelength. What's yours? Leave us a comment. And here's an extreme close-up. Whoa! In 94 angstroms. And the reason we use 94 angstroms and 131 is because they take more images. Those wavelengths take 10 images per minute instead of only 2. And the 94 and 131 angstroms wavelengths are specifically formulated to study solar flares. Here's a close-up in 171. And we're also going to show you the coronal hole, which is sending protons all the way to your local magnetosphere, causing a geomagnetic unrest period and probably a storm at magnetospheres near you. And there's that coronal hole associated with the North Pole, the North Solar Polar Field-oriented coronal hole. And we are out. Thanks for tuning in, folks. Remember, stare at the sun, don't drink, and if you do, don't drive. Certainly don't drive. I don't want to see you out there. And certainly don't drive to Pennsylvania. It's a fascist you-know-what hole. No matter how much the government drives you to drink, only do it if you want to. And certainly, if you do it, don't drive. I've been your host, Dan, a.k.a. smAsho. may that solar wind be at your back. And thanks again for leaving comments. Twitch viewers, cheers to Naples, Italy from